Ever looked at mold assembly drawing and thought, what on earth I am looking at? Today I will show you how to read the core, cavity and insert layout step by step so you never feel lost again. Welcome back to UG Mold Tech, where we make the mold designing simple. By the end of this video, you will be able to exactly identify the core, cavity and different insert in a mold assembly drawing, just like a professional mold designer. So friend, let's start our today's topic, how to read the mold assembly drawing including core, cavity and different insert. Basically, what is a mold assembly drawing? A mold assembly drawing is like a map of your entire mold. It shows every major component from plates and ejector pins to the cooling channels and inserts in a single view. If it has a slider lifter, it will show in the single view. See the assembly drawing step by step. There are mainly 4 steps to see the assembly drawing. Firstly, we will see the 3D of this tool so you understand properly. So friend, we check the 3D of this one. Okay, this is the 3D. This is the 3D of that tool. This is the 2-plate mold. Okay friends, I will show you the section of this one also so that we can understand properly. I'll show you from this side, this side. You can see. Okay, you will see from the top also. This is the register ring. We go from the top plate. Okay, you can see the screw bush also. This is the cooling channels. This is the cavity plate. Then we are going to core plate. This is the cooling channel also, you can see. Now we will going to our spacer blocks, ejector pins, ejector plate, ejector back plate, okay, and the bottom one. Okay friends, this is the mold. We are going to see the assembly drawing. For this we are going to see the assembly drawing of this tool. So we go to, so friend, we start with the 4th step that we follow to read the mold assembly drawing. First we have to start with the title block. See the scale. Okay, what is the scale? Okay, what is the material used? PBT plus glass with 30%, sinkage 1.04, number of cavity 1 by 1, 1 plus 1. Okay, you can see the scale and see the angle of projection. This is the first angle, drawn by and designed by, checked and approved will be done by handwriting. Okay, this is the first step. You should check the title block first. Okay, the next step will be identify the main plate. You know there are 2 halves. First is moving half and fixed half. Okay, this is the moving half. This is the fixed half. This is the plan view of fixed half. This is the plan view of moving half. Okay, the second. Okay, the next will be our locating the core and cavity. See, this is the cavity plate, this is the core plate, and this is the different insert. The last point will be our to identify all the small components. It may be cooling channels, insert, sub insert, if it is a slider or lifters or any other component or ejector pins. Okay, this will be the last step. First will be blocks. You have to check the title block. Second, identify the moving half and fixed half. Third will be core, cavity. Okay, and third will be other inserts and special features like cooling channels, ejector pins and lifter or slider it has. Okay, you should follow this step friends. The next part will be our understanding the core and cavity. As you know, the core form the internal feature of your plastic part. Okay, this is the core. It will form the internal feature of your plastic part, and cavity will be from the external. It will give the external shape of your part. It will mostly fixed in the side of injection unit. Next will be friends the inserts. You can find these are all sub insert. We will see the separate drawing for this inserts also. Why it is done? Insert are the precision feature. You do not want to cut the main plate, okay? Just you do not want to cut all main plate, okay? That will be very costly. The insert allow you to change the design, improving wear resistance, and help you to fall with the complex shape without changing the whole core or cavity. The insert are a precision feature, and the type of material is mostly P20, S13 or D2, etc. And there are various inserts are there, like core insert, cavity insert, lifter, slider insert, gate insert, screw insert, locating ring, guide pillar and bush, and wear plated. These are the sub insert of your tool. And the benefits of using the core and cavity insert are cost effectively. You just replace the inserts. You do not have to change the whole mold plate. Okay. The second will be our simplified maintenance, easy to remove and fix another wear or tear parts. Improvement in improve precision. Insert can be made from high grade material and finished to the tight tolerance. Okay, these are the main feature of our why we use inserts in the core or cavity or different components. And the next point will be our gate, runner and venting. We have to trace the flow of our plastic part, just like going from screw to runner to gate, okay, maybe sub runner also there, and to finally to the part. You can see this is the screw, it is going through the runner, and then this is the edge gate, and to the finally to the part. Okay, you should find the gate may be submarine or edge gate or pin gate or fan gate. It depends upon the product. You can see the runner, check the location, and if it is not in, should not come on the cosmetic phase. Okay, and the next point will be our cooling channel. Okay, cooling is half the mold performance. Reading the cooling schematic and plain review. Okay, maybe C1, C2. Okay, this is the cooling channel. It may be there are different types of cooling also there. Straight dealing, buffle, bubbler, spiral, conformal, inserts. Okay, these are the cooling, different cooling systems. And the next point will be our ejection system and the moving element. Now verify how the part leave the core. Okay, the key components are ejector pins. Okay, the stokes, how it land on the ribs or boss. Okay, its component are ejector plate, ejector back plate, return pin, stop pin, springs. If it has a slider or lifter, you see the travel plate looking forward. So these are the ejector element of our mold system. Okay, I hope you clear up to this one. The next will be our friend. Now we see the different sub insert in a mold. We will see in the 3D as well as 2D drawings. And this is a 3D model of our core insert. Okay, how it is drawn, we will see. See, this is the core insert. You see the first title block, what are the things are given. Mere core insert, it is a see the dimension 160, okay, and the material S13 or 2344. The HRC is 48 to 50, quantity is 2. So mostly this job is done in CNC, so we have to just mostly give the reference from here. It is 00, go up to 80 here, so 160. Okay, this is the section view. These are the some control dimension also we have to follow. This is a 10 micron. Okay, plus it should not be in the -1. Okay friends, next we see one more other insert. And this is a core insert. Okay, this is a sub insert. There will be a cavity plate, core insert, and this is core sub insert. Okay, we will see the drawing also. This is the drawing for core sub insert. You can see the dimension, material, quantity, and HRC all are written. This we have to draft and give to the shop. Mostly all maximum things are done in EDM and CNC. These are all the control dimension. I hope you cleared about code insert and code sub insert. We will see some other insert also. And you can see the 3D of this puller pin. Okay, screw puller pin. We will see the drawing of this one also. And this is the drawing for our screw puller inserts. Okay, it will pull the screw. Okay, you see the dia is 5 and it is x7. This is the length. Okay, here we have done a section also. I hope you understand this also. So friend, we will see how to read the new drawing in one pass. Okay, you can say the checklist, okay, or routine checklist. Okay, if you get a new drawing, always check the unit scale. Okay, cavity side, A side, B side. Okay, match with the BOQ, type of gate used, maybe pin gate, edge gate. What are the different gates are there? You check the cooling space. Okay, ejector pin, how it plus toe. Okay, check out the fits, about the surface finish. Okay, these are the main point you should always check when you receive the new drawing of a plastic injection mold. So friend, now you can read the mold assembly drawing with confidence, from core to cavity to orientation to every insert and tolerance. If you find this video helpful, hit the like, subscribe and comment. There are a lot more content coming upon your way. We will see you in the next one. For now, it is bye.